kids today and your rechargeable devices, you don't know how to change batteries. Here, try this. There you go.
What do I do with it?
You press lay and you plug it in.
Dad, it's not working.
Call me CircuitSlacker.
Dad, it's not working.
Ah, it's broken. Good.
My first experience with this Koss Tracker PP320 AM/FM cassette player was very similar. After paying $1.50 at Goodwill, I brought it home, installed batteries, inserted a cassette, and plugged in my headphones, and found the jack to be a little loose. Because of how the headphone jack is positioned inside the case, I thought the repair would be simple. In the past, I've had many headphone jacks loosen themselves from a circuit board, and that's an easy fix. All I need to do is open the case and resolder the jack to the board. There are 4 screws to remove. The case doesn't seem to want to come off. The volume and function controls must be holding the case to the board. After some additional nearly destructive investigation, I found the problem. Turns out there are 5 screws holding the case together. Now I have 2 repairs: solder the headphone jack to the board and fix the function lever. Turns out the jack hasn't come loose from the circuit board has come loose from the circuit board, with the jack still on it.
Oh, it's fixed. A little super glue and we'll be done.
If the piece of circuit board had some sort of physical support to the player's structure, I could have jumpered it. But if it had some sort of physical support, it wouldn't have broken off in the first place. I'll have to come up with some other solution. Before we spend too much time on this cassette player, let's see if it even works. I'll connect an amplified speaker to the circuit board. Now, about that broken lever, gluing it back together won't last because it's a mechanical stress point. I'll have to copy the design and 3D print a replacement. I'm familiar with SketchUp, but my only Windows computer is a tablet. I know I could run it in Linux through Wine, but it's easier at this point just to use the tablet. Of course, I use the inner diameter measurement of the circular portion of the lever as the outer diameter measurement in my design, so after printing version 1 and finding it didn't work, I had to modify the design and print version 2. I decided that the way to resolve the headphone jack issue is to solder a length of cable to the circuit board and use a screw to mount a cable clip to hold it all in place. Once the cable is soldered to the board and jack, I won't be able to completely remove part of the case as the cable will be tethering it. So I'm using a length of cable sufficient to allow for future repairs if necessary. Using a cable clip design found on Thingiverse, I printed cable clips of varying sizes. Now that I have the replacement lever printed and an idea of how I'm going to repair the headphone issue, I need an external headphone jack. The jack I bought at Fry's, and the audio cable is from an old CD-ROM drive. I'll use some heat shrink tubing to provide a little strain relief on the jack side of the cable and to mask the mismatched sizes. Now I need to double check the actual connection points and make sure that the right channel will play in the right channel and the left channel will play in the left channel. In a stereo headphone jack, the tip should be the left channel, the ring should be the right channel, and the sleeve should be the common ground. Color-wise, left should be white, right should be red. I'll use the original jack to determine which pins correspond to which solder joints on the circuit board and solder the correct colored wires to those locations on the board. The ground wire has pulled the trace from the board, but fortunately that's okay because this trace is connected to the rest of the circuit at another location. With the strain relief clip in place, this will not be a problem. I had intended to lock the cable in place at the point it exits the player's case, however the cable clip that is screwed through the circuit board holds the cable very well and additional support doesn't seem necessary. Let's check to see if putting everything back together is feasible. The strain relief clip is relatively large for where it needs to be inside the case. The function lever is ever so slightly longer than the original, and it's very loose. A washer helps breach this gap, and the original actuator that screws onto the top of the post fits perfectly. Time to get the Radio Shack helping hands out to solder the jack to the cable. Now the headphone repair is completed, let's give it a try. It would help if I plugged the other end of the cable into the amplified speaker. Thankfully, I remembered to run the cable through the headphone opening in the case and to add the 2 sizes of heat shrink tubing and the jack's outer cover before soldering the cable to the jack. How about the radio? The radio reception isn't great. Now that it's working, it's worth cleaning up. Every electronic product I've ever purchased at Goodwill has come with a code written in marker. Thankfully, the marker is easily removed by covering it with dry erase marker and wiping it off. I compared this method to isopropyl alcohol, and the dry erase marker is much faster. The audio playback head is playing fine and looks very clean, so I'm going to leave it and the capstan spindles alone. There's an obvious correlation between the AM/FM cassette players of the past and the iPods of today. When I noticed that this cassette player had an alarm clock on it, it made me think about these kids today and how they use their devices for an alarm clock. They don't have regular clocks. I wonder if a kid in 1995 would have used this thing to wake up in the morning. There are 10 radio presets which can be either AM or FM stations, and there is a bass boost feature that works with radio or cassette. Earlier I had noticed that the tuner on this player seems to pick up more frequency deviation from an FM station's carrier frequency than an iPod Nano. I performed a comparison. It's designed for international use and steps in tenths of a megahertz, whereas US FM radio is channelized into only odd tenths of a megahertz. The Koss locks to local station 102.5 when searching. Tuning up to 102.6, then 102.7 produces some audio from the main carrier 102.5. The same test on an iPod Nano rejects the deviation from the 102.5 carrier when tuned to 102.7, unlike the Koss. There is one more thing I've noticed. When the cassette player's motor is running, there is motor noise in the audio. I don't know if this is part of the original design or if a filter capacitor is wearing out. It's definitely noise from the motor. The frequency is relative to the motor spinning. I thought about adding some ceramic capacitors to the motor to see if I could filter the noise, but my ceramic capacitors are in there, somewhere. Since 1995, when I lost all of my cassettes in an auto accident, I've had little use for a cassette player. In the early aughts, I would record Coast to Coast AM with Art Bell on a 90-minute cassette and listen to that during my 90-minute round-trip commute to work. Well, I traded that car in 2003 and had now a car that had no cassette player but a CD player, and since then had no use for cassettes. In 2017, nostalgia is a cheap hobby, and this portable cassette player works great when I'm playing those 69-cent cassettes that I'm picking up at Goodwill. Repairing something that I could easily replace makes the listening experience that much more enjoyable.